Good morning, everyone. I am Dr. Chandani Nair. I am going to handle physical chemistry 3 for you. Before going to the topics of physical chemistry, we will just have a cartoon first. Do you remember 25th March? We all were forced to go to home or go and sit in the home, and lockdown was announced. Now what is the condition? We all are forced to come for the work. So we are going to have our online classes. Take it as usual, study properly. Okay, now we'll go to the topics. As usual, physical chemistry has 5 units. First unit is thermodynamics 3, second unit is electrochemistry 2, third is surface chemistry, fourth group theory, and fifth one spectroscopy 1. Now unit 1 is thermodynamics 3. We already have studied thermodynamics 1 and 2. We'll see what are the topics comes under thermodynamics 3. Van Dorf's isotherm and isochore, Clapeyron equation, Clausius-Clapeyron equation, third law of thermodynamics, Nernst heat theorem, absolute entropy from heat capacity measurements, partial molar properties, Gibbs-Duhem equation, concept of fugacity and activity. Okay, before going to the present topics, we'll have a recap of thermodynamic 1 and 2. Okay, in this class I will be summarizing what is the definition of thermodynamics, certain terms like system, surrounding, boundary, types of system, properties, state of a system, equilibrium and processes. Okay, now what is thermodynamics? You all will be saying, I know it's a science of energy. What is energy? In simple way we can say it is the capability to do work or ability to do work. So what is thermodynamic? It's a science of ability to do works. And earlier when it was developed, this thermodynamic got its name from two Greek words. One is thermi and one is dynamics. What is thermi mean is it is heat, and dynamics means it's power. So something related to generation of the power by using current. Or in early 19th century, what is the definition given is the study of generation of power from heat is what is known as thermodynamics. As days go on, it has been applied to various things, and its definition has been changed. Now we call thermi as energy, not heat, all forms of energy, and dynamics is transformation. So what is the energy changes occurring during any transformations is what is thermodynamics, or the study of changes in energy associated with physical and chemical transformation is what is known as thermodynamics. Then its application or where we can found it is it's found everywhere in life, starting from pumping of the blood, refrigerator, automobiles, aircrafts, etc. All the applications or all the science branches we can apply thermodynamics to all branches of science. Now when we go into the thermodynamics, it's must that we should know what is a system, what is a surrounding, and what is a boundary. So system is that part of the universe chosen for study of thermodynamic observation. When we do the thermodynamic studies, we will be performing that in a part of the universe. For example, if you are boiling a glass of water and you are going to find out what are the changes occurring there, means that water inside the glass is what is known as the system. So that part of the universe which we have chosen for thermodynamic observation is the water inside the glass. Then the remaining portion, that is if the glass is kept inside the kitchen, the whole kitchen or remaining part is what is known as surrounding. So when a glass of water is heated, some heat energy may be going into the room, or it may be absorbing some heat energy, all that changes we used to study. So remaining part is what is known by the name surrounding. Then boundary. Boundary is a real or an imaginary surface that separates system and surrounding. When you take the case of a glass of water, the walls of the glass, we can take it as a real surface which separate it from the rest of the room. So that is what is the boundary. And when we take the system, it can be a simple ice cube or it can be a aircraft. So it can be from a simple form of ice cube to a very complicated or sophisticated aircraft can be taken as a system. Now when we go for the further, we have to see what are the interactions taking place between the system and surrounding. So when we take the case of thermodynamics, we mostly will be dealing with matter and energy. The system consists of some matter and energy. So how it interact with the surrounding and system, we will be taking. Anything that is either matter or energy going into the system will be represented as positive sign. For example, if you are taking energy, for example, if you are taking heat content, enthalpy, we will write if it is the change in enthalpy is positive, means what you have to remember is it is increase of enthalpy of the system. Energy has gone from the surrounding to the system, and anything which comes out of the system will be represented by negative sign. That is, the system loses it. Matter if it comes out means it will be losing it, or energy comes means it will be losing. Therefore we denote by negative. Loss we denote by negative, and gain we denote by positive. This is very important. You have to remember this always. Okay. Then next, based on these interactions, system can be of open system, closed system or isolated system. Open system is a system where the system can exchange both energy and matter with the surrounding. The system can both matter and energy it can exchange. What is closed system? It can exchange energy, but matter it won't be able to exchange. Matter cannot be exchanged, but energy can be exchanged. Then isolated system. Isolated system is a system where both matter and energy cannot be exchanged with the surrounding. Examples, when you see, you can take water in an open saucepan. If you take water in an open saucepan and heat it, what happens? Once the boiling point is reached, the water will escape to the surrounding. If you keep it as such and we forgot, means after half an hour when you come and see, there will be no water inside the saucepan. So that is a system known as open system, where it can exchange the matter and energy with the system. Then next is closed system. It's water in a closed vessel. If you close that saucepan with its lid and again heat it, means what happened is the vapors will go and hit the inner surface of the lid and it will condense and come back. So matter will not be exchanged, but heat energy can be exchanged with the surrounding. And next is isolated system, that is water in a vacuum flask. You know, when you take the flask, why we use the flask? To maintain the temperature. If you need hot or cold water for long time, we used to store in a vacuum flask. So it has a surrounding which will not allow the exchange of energy with the surrounding. So that is an example for isolated system. So open system can exchange both matter and energy. Closed system can exchange only energy, whereas isolated system can't exchange both energy and matter. Then properties attached with a system. Okay, you have seen volume in the diagram. If you see, what is the thing is, you can see a balloon. Okay, if you blow it further, what happened? The balloon become more. And what happened? We are adding air to it, and due to the addition of the matter, there will be an increase in the volume. That means volume depends on the quantity of the matter present. Now you take the case of temperature. You take 30 ml water, increase the temperature only at 100 degree centigrade, it will start converting to vapor. And you take in another vessel 90 ml of water, heat it only at 100 degree, it will also boil. So boiling point of 30 ml water or 90 ml or 1 liter water will always be 100 degree centigrade. That means boiling point did not depend on quantity of the matter. So based on these observations, you can say that there are two types of properties. One we call it as extensive property and another one is intensive property. The property that depend on the quantity of the matter in a system is what is known as extensive property. We have seen the volume. Then the property that do not depend on the quantity of the matter in a system is what is known as intensive property. The temperature or boiling point we have seen. Or you just remember that you are having a glass of water, 50 ml water. Okay, it will have a temperature, pressure and volume is 50 ml. You are going to divide it into two parts. So what happened? The temperature and the pressure of the water remains the same, but volume will be divided into half. That is, one part will have only 20 ml, another part 25 ml, another part will have also 25 ml. So volume has reduced from 50 ml to 25 ml. So that type of properties which depend on quantity of the matter, we call it as extensive property. Which do not depend on quantity of the matter, we call it as intensive property. Example for extensive property is mass, volume, height, enthalpy, whereas intensive property is temperature, pressure, density, refractive index, etc. Now, state of a system. State of a system is a condition of the system where all the properties can be measured and gives a complete information about a system. That is, example, you take a cup of water. We can measure the temperature, we can measure the pressure, what is the volume and all. So that condition where we can measure all the properties only, we call it a state of a system. And that condition you can take it as that there is no transformation occur, the system will remain as such. If any one of the property changes, it changes its state. For example, the glass of water you are taken at room temperature, you are going to increase the temperature, means it will be transformed from one state to another state. So what is the state of a system? A condition of a system where all the properties can be measured or all the properties are fixed is what is known as state of a system. Now, next term is equilibrium of a system. Equilibrium as such, what is the meaning is a state in which opposing forces are balanced. For example, if you take a reversible chemical reaction, when the rate of the forward and the backward reaction is same, we call it as it attains equilibrium. Or the speed with which reactants is converting to the product and the product converting back to the reactant is same, that condition is what is known as equilibrium. Then a system is said to be in thermodynamic equilibrium when no driving force is there to change any property. The system should remain in the same condition. There should not be change in any of the property. If any one property is changed, we call it as not equilibrium. So that state where all the properties remain same is what is known as thermodynamic equilibrium. And when we consider the case of thermodynamic equilibrium, we used to take we consider the system should be mechanically in equilibrium, thermal it should be in equilibrium, it should have phase equilibrium, and also chemical equilibrium. What is mechanical equilibrium is there should not be any motion inside, the molecule should not move. That is what is mechanical equilibrium. Then thermal equilibrium means there should not be any change in the temperature. That is, if you take a glass of water, throughout the water it should have a same temperature. Maybe on the top if it has higher temperature and bottom lower temperature, or in reverse we can't call it as a thermal equilibrium. From the top to bottom, if it contains 100 molecules of water, all the 100 molecules of water have the same temperature. That is what is known as thermal equilibrium. Then phase equilibrium. Phase equilibrium you can say in the case of a two-phase system. For example, you take the case of the same thing, water boiling in a closed vessel. So when you are taking the case of the water in a closed vessel, what happened is water will be converted to the gaseous state, that we call it as water vapor. So there will be some amount of water vapor and there will be some amount of water. So if you measure the mass of it, if the water is weighed as 2 gram and water vapor is 1 gram, you are going to convert the temperature from 20 to 35 degree. At that time also, if you measure the mass, if it remains same, that is water vapor should remain 1 gram and mass of water should remain 2 gram, that condition is what is known as phase equilibrium. Then chemical equilibrium means what? Composition of the system should not change. Composition of the system should not change means there should not be any chemical reaction. If a system maintains all this equilibrium, then we can call it as it exists in a thermodynamic equilibrium. If any one is not maintained, we can't call that system as a thermodynamic equilibrium. So what you have to remember is, for a system to remain in thermodynamic equilibrium, it should attain mechanical equilibrium, thermal equilibrium, phase equilibrium, and chemical equilibrium. Then processes. What is a process? A system in one state, if when it is converted to state 2. How will you identify that a system is converted from state 1 to state 2? That we can see by change in property. So that property is what is known as process. So a process is defined as a change or transformation of one state to another state, and it is determined by change in property. That is what is known as process. Now process, if you take, there are different types of process. One, we can call it as iso. Iso means constant throughout the process. So when you take the iso word, you can say that there are three types. One is isothermal process, one is isobaric process, and one is isochoric process. Isothermal process, isothermal, constant thermal property, that is temperature remains constant throughout. Isobaric, bar is the one which is used to determine pressure, so that means pressure remains constant throughout the process. An isochoric process where volume remains the constant. So iso, when it comes to your mind, you should remember that any one property remains constant throughout the process. So it can either be thermal property or pressure or volume. Based on that, we have isothermal process, isobaric process, and isochoric process. Now we have another one type of process which we call it a cyclic process. Cyclic process is a process in which the initial and final state is the same. That is, if we start a reaction and it occurs through a large number of processes and comes back to the same initial state. We call it a cyclic process. For example, if you are heating water from 30 degrees centigrade and through lot of process and finally we get the water at 30 degrees centigrade, we call it as cyclic process. Then another one type of process is adiabatic process. Adiabatic process is a process which occur without transferring heat or mass between a thermodynamic system and its surrounding. Heat energy will not be exchanged between the system and surrounding. That type of process we call it as adiabatic process. Okay. So these are the basics of thermodynamic one. We'll conclude now here because you can recollect it once more all the things. So what are the things we have seen is definition of thermodynamics, definition of the term system, surrounding and a boundary. Then we have seen what are the types of properties. Then we have seen state of a system, equilibrium and also different types of process. We will continue in the next class. Thank you very much.